by the way, I sort of decided this, and now I'm considering it again. There's the disk section that we talked about. Yes. Oh shit. So if you miss some classes, oh shit. I give you a function, you rotate it around an axis, and then you find the volume of that rotated shape. Yes. Oh yeah. Exciting stuff. Yeah. Here, while I'm thinking about it, would anyone like the for me the incredibly colorful handout related to that?
Yeah, I know.
Oh, anybody else need or want that? What are you talking about? You didn't do one of those? You got them, did you?
Did you hang out both places already, Joe?
Yeah.
I only got one.
Weird. Oh, I do have some corrections people made. Corey. That's weird. Let's see. Yeah, Jason. I'm pretty sure I gave them all back. Neato. Well, let's both take a look. Eventually.
You handed both back today?
Not today, no. Last time I gave it back was 6. Last time, yeah. So here's what I want to do. I want to talk a little bit about, well, I'm trying to figure out which order to do this in. Yeah, let's do this. I think what I'm going to do is I'm going to focus today on the test. And by the way, I'm coming up with this right now, because I had a different plan earlier. Today, let's focus on this next test. And this next test will not include disks or shells. We did talk about disks. I have no qualms giving you a disks problem on the final. And you're all like, yeah, we know, you're jacked. I will talk a little bit about shells the first thing on our day of review for the final. We'll see what I think. We'll see what I do. I'm pretty sure I'm not going to make it too, but I at least need you to know they exist. Okay. But today I've just decided, let's just focus on only what's going to be on this next test that's happening this Wednesday. Do we have, if there are no questions, I might do some, make you guys do some stuff, we'll see. So it's up to you, either ask questions or I'll put you to work. If you guys no questions, then I'm like, they want to work. Yes.
I have a question for the test. So it's chapter 5 to 6.1, 6.2 to 6.0.
That's right. It's officially section 4.9 through 6.1. Yes.
And then the other ones will be on the final.
Yes. Most likely I'm going to put 6.2. 6.5 is hilarious, by the way. All right. Let me talk about 6.5 real quick. How do you find the average? All right, here. Let me just do this. Let me do this. You know, you're a teacher, man. Just do what you're going to do. If I had this shape. Okay. You can tell me the area of the shape. Yes? Easy. Do you need calculus? No. Could you use calculus? What'd you say? No. That's right. You could, of course, because that's what integration is built for, is finding the area underneath the curve. If you find the equation of the line, you can use calculus, and then somebody using geometry would be staring at you as you do all this shit. They're like, what are you doing? You guys would. So this is a huge lesson about math in general. You're going to learn more and more complicated ways to do things that make sense sometimes. Calculus is one of those things. If I had a curvy shit, I don't have a freaking geometry formula for curvy freaking shit. I have a geometric formula for triangle. So if you're going to go much further in mathematics, you have to be able to step out of the problem you're currently working on and say to yourself, is there a simpler way in this situation? Alright, I'm sorry. If I wanted to know, you guys could tell me the area. Does anyone know the area under that line? The area of this triangle? Yes. 1/2 base times the height. Yes. I want to know the average height of the triangle. Well, now on average, how high does it get? Like here it's 0, yes? And here it's 2. So on one level, your immediate response should probably be 1, yes? Doesn't that make sense?
Yeah.
The minute it's curvy though, then it gets a little bit trickier. Are you guys all with me? But even when I make it curvy, okay, why was this easy? It's a linear relationship. So half the time it's below 1, half the time it's above 1. So of course the freaking average is 1. But if I have a curvy dude, then it's not half and half. It's who the hell knows? Maybe. And then if I'm an exceptionally curvy dude, then I'm like, I don't know. So here. Believe it or not, this is an associated idea. If I told you I had a rectangle that was 7 inches long that way, but I'm not going to tell you this way, but I know the area is 35. How tall is it? Correct? Yes? If I know how long it is and the area, of course I could figure out the stupid height. Yes? Now, I want you to realize, that what you're giving me though, did I say rectangle? Okay. If it's a rectangle, then it's 5. If it's a triangle, then it's got to go up higher so that this triangle fills in that triangle. If it's a curve, then it's got to kind of do the same thing. So here's the idea. If I want to know the average height, it is exactly equal to what would be the function if it was a rectangle. What would be this? So the area of this is 2. You didn't make it back, bro. Ooh, I got this cool. Look at this. By the way, sorry. Ooh, excuse me. Okay. Area is 2. And if I say, okay, what's the, get out of there, Jeff. Area is 4. If I say the width is 4, how high would the rectangle be that has the same area? How high would the rectangle be that has the same area? The width is 4. The area is 4. If the width is 4 and the area is 4, how tall would it have to be?
It's a triangle, so.
No, I said the rectangle with the same area.
Oh,
It would have a height of 1. Okay, good. Yes? So in general, here's all 6, 5 says. If you want to know the average height of a function, that is the same thing as figuring out how tall would it be if I shoved it into a rectangular shape. It's kind of silly. So do it again?
Can you repeat that?
Yes. So if I give you some function that sounds like that, and I want to know what's the average height. On average, how high does this get? Yes? What I can do is I can integrate and then I can divide by the width. Isn't that what we've been doing? The area divided by the width. The area divided by width. What that does physically is I shove it down until it becomes flat. I like bonk this and this goes up a little bit, and I bonk this and this goes up a little bit until it's flat. Same area, but I flattened it, and then I can see what the average height would be. That's all 6, 5 says. Now, I want you to realize, it took me a little while to explain this, and some of you guys are still like, I don't know what the hell you just said. But that's all it is. Integrate. One more step after you integrate. Divide by how long of an interval it was. So if I was integrating from 1 to 4, I would divide by 3. Do you understand? 6, 5, a slightly funky idea, but a very, very silly nuts and bolts, you barely do any more work than normal. Do you guys? Have I asked you to integrate stuff before? Yes. Now 6.5 would just be integrate the stuff, but then divide by how far it went. But I love this idea of it's just reorganizing it to a rectangle. Because what's the easiest shape to know the average height for it? A stupid rectangle. So if I take whatever the funky shape is and I smoosh it into a rectangle, then I can see the average height. It's just the area divided by the width, which is what you guys did earlier. Okay, enough of that. So 6.5 is kind of silly. It's like integrate and then do one more thing. Okay. Sorry, I just had to because it's just such a silly thing. So the rest of today, if nobody has any questions, then we'll see what I do. Do you guys have any questions for the quiz? Do you guys have any questions for the practice test? Do you guys have any general kind of questions you want to go over?
From section
5.5? One of my personal favorites. And what you got? 80? 88. Okay, so bacteria population starts with 400 bacteria, grows at a rate of that per hour. How many bacteria will there be after 3 hours? So we know the rate of change of population, yes? So I know, let me see if you guys are cool with this. Is somebody with me on that? They tell you it's growth at a rate, correct? So let me put it into calculus terms. So I'm trying to show you, because it's been a long time since I even looked at this problem. So this is me looking at the problem fresh. First thing I'm doing is I'm going to translate what they tell me in terms of calculus so I can see a connection to the processes we talked about. That is the change in population over time. So like dp dt equals, you can do it, Jeff. Where'd it go? There it is. 450.268 e to the 1.12567 t. Jeebus. I haven't done much of anything, correct? I haven't done shit. Do you all understand, number one, my holy shit after a holiday, your writing gets even worse. But number two, do you understand the only thing I did was replace R of t with dBdt. Say flat. All I did was replace R of t with dBdt.
Oh, that's a B.
That's a P.
Oh.
dPdt. It's hard to say dPdt, believe it or not.
Yeah, no, I get
Does everybody understand why I did it? It doesn't feel like I've done shit, correct? Do you understand that that's okay to do? Does everybody get that's what's going on? What does R represent? What is R? The rate at which what? Yeah, I'm covering the problem. I'm sorry. The rate at which the population grows, correct? So what's a better way to say it instead of R of t? dP dt, correct? Now what are they asking me about? How many bacteria? So they want to know what P is at a specific time. I need you guys with me on this. This is actually big what we're doing right now. So I really appreciate this question. You see how they ask this? A huge part of calculus is writing symbols that captures the idea. Yes? So if I'm seeing a rate of change in population over time, that is dP dt. That's what I could write. This problem is beautiful because it shows you that stupid little thing, that dumb little thing where I'm just being a math teacher going, oh, you could write it like that. It leads to what I'm going to do next. I want to know what P is. Yes? How do I undo what's been done? What did somebody do to P? What did somebody do to the population formula that I'm trying to get back? What did they do? They took a freaking derivative. Those dumbasses. I couldn't do it. No. You guys with me? how can I recover what the population function was then? Take an antiderivative, right?
First you isolate, like you myself, right?
Oh, I love it. Oh, Ezekiel, you kick ass. That's the next question, and you're like, let me speed this along.
And then we can just take the antiderivative.
Kick ass. So if you multiply both sides by dt, I can then integrate both sides. By the way, quick side note, can you guys tell me, what's the integral of dx? X. What's the integral of dn? What's the integral d? Let me really trip you out. dxy.
XY plus C.
Yes! I'll calm down. Yes. So, if I multiply both sides of this by dt, oh my god, why did they choose these freaking numbers? Do you see all I did was multiply by dt? Now you can see it. Why is there an extra t there, Jeff? I don't know. It's supposed to be up there. There we go. Then I could do this to both sides. What's the integral of dp? P. Then I get the population function. So did you have to necessarily write it exactly the way I did? No. You could have just said to yourself, oh, this is the rate of change of the population, and they're asking me about I gotta get the population back. I have to undo what they did, I have to integrate what they did. Those jackasses. And then you would integrate this, yes? This is just a way to kind of like in your face show you the usefulness of these symbols. Okay, maybe. I see some of you guys are with me a little bit. The rest of you are like, you're not gonna put a problem like that on the test, are you? That could be why I'm really happy some yeses. No. So here, I'll do half the problem. There you go. And you guys can do that. Now they tell you specifically after 3 years, but once you get now here's the tricky part. When you integrate that, what are you gonna get like we just did? The answer wasn't integral dx was not x. The integral dx was x plus c. You are gonna get a plus c. So how the hell do you find out what c is? Do we have any information at all? What do we know? What do we know? Say again. The starting population when t was 0. So we have a point, 0, 400. I think it was 400, yes? So then I can figure out what c is. Do you guys see what I'm saying? So I'm gonna let you do the math, but do you see how everything comes together in this word problem? How could I figure out what c is? They have to give me more information. Did they? Yes.
Well, I think you mentioned like there's no like wasn't it like an oil like 1800 and it's how much it's going to
Sure.
So at 0 time, right, when it's punctured, there's no oil.
True.
So C would be 0 by that logic.
Yes, in that case, yes. Bless you.
Okay.
Yes. Bless you. You're exactly right, Ezekiel. All right, is that okay for that problem? That's a really good question.
Yeah, I should figure out. I remember how like the integral ology.
Now look. That integral looks really bad just because of the stupid numbers. Even without replacing the numbers, can you look at that and see what's important? What is the only thing that's important in that integral?
The E to the
It's e to stuff. In fact, it's e to linear stuff. Now I know this is in the u subsection. Can you guys?
just
I know this is in the u subsection, but you don't need u sub for this stupid shit. What's the integral of e to the t? Let's start there. That's insane. Plus c.
Yeah.
What's the integral of e to the 2t? No, it's not this. Why can't it be this? This is not the answer. It cannot be the answer. Because what's this guy's derivative? 2e to the, okay, divide by 2, yes? So what's the integral of e to the at? You can do it.
E to the 8 over 8
Yes. So when it's linear, I don't need u sub. Can you use it? Of course you can, because that's what its job is. Do you need it? No, you divide by the dumb number that would come out. Now, I do like to show you that. But then some of you guys do that even when it's not linear. If that was e to the 2t squared, I'm screwed. I hope a t's out there and I can use u sub then. But if it's linear, It's just a number. You can divide by the dumb thing. Maybe some. You guys see how you could use u sub here? Does anyone see how you could use u sub here? What would you let u equal? 2t. And then du would be 2 dt. And then I would need a 2 in front of dt, and I would put a 1/2 out front. There's the dumb 1/2. There it is. There it is. So when it's linear, I don't need u sub, just extra work. But again, you could use u sub. Anytime the interior thing is not just plain old x or plain old t, you could use u sub. But I'm hoping some of you guys see, if it's a linear thing, I don't need that. I could do that. Constants do what we want.
Right, so it'd be like.
Yeah. E to the AT, where A is 1.12, whatever the shit that was, right? So do you guys see how you're just gonna when you integrate, you're just end up dividing by the number in front of the t, just because that's what A is, yes? Okay.
I'm trying to figure out what because it's not gonna be 1.125.
Like 2 point.
The what now? Sorry.
The exponent.
No, the exponent
Plus
has
one.
to stay the same.
I would t to 2
No. If it is 2t, it's
Oh,
still
wait,
2t. If
right.
it is AT, it's still AT.
Right, stay the same. So I looked at
Yeah.
that. Okay.
When you differentiate stuff with chain rule, does the inside change? No. It gets its own turn. When you integrate stuff with stuff on the inside, does the inside change? No, same reason. Right?
When you just substitute 400 over T and so for C2,
I think it's 3 hours, so was it per?
but the population starts at 400, so you need to know C at 400?
No. So T starts at 0. And it goes to per hour, so it goes to 3. So it'd be from 0 to 3. Yeah. Or you could just get the population function by itself, have an indefinite interval, and then plug a 3 in. Yeah, that's what I would do. Is that all right?
Okay.
This didn't have to be in the use subsection, but they were just being careful. I really like that problem because it's so compact, so little said there, but there's a ton of shit there. And you're all like, that's exactly why I hate the damn thing, Jim. And then you see these things that are like paragraphs, and then it's a stupid little thing you have to do. It's like, all right, that I hate, that I don't like. Don't make me read all this shit and there's nothing to do.
Although the weird part, the funny part is technically it was testing how much before you don't get to 40 hours.
Yes.
Actually, which then plugs in free for that.
Yeah, you have to add the 400 in for the beginning. So if you integrate from 0 to 300, when you plug a 0 in, you will get 400. So if you do it that way, it's all there, I guess. That might be better. Instead of having to remember to add the 400 that was there at the beginning. Either way, there's 2 ways to do that. Okay. How's that? Is that okay by itself? Is that okay? I think there was a problem like that. Did I give you the solar power problem? Was that on this last practice test?
Yes.
Yeah, number 5 is my slightly easier to look at example, just like this. You guys see that now? If you look at number 5 in the practice test, do you see how it's exactly this? Okay. So that might say something about whether or not something like this will show up on the test. It was in the homework, it was on the practice test. Who can say? Who can say? I don't even know myself. Sorry. Huh? What?
I'm like, I think you do.
I think I do, that's right. Call me out my bullshit.
So for 5A, it's just finding the answer.
5A. Oh, literally, yes. So part A is just find a formula,
So it's just the answer.
and then part B is solve an equation based on that formula you get.
Okay.
The only difference on mine is I don't talk about the time, I talk about, so you're not gonna plug in for T, you're gonna set your formula equal to 1500. Yeah. Is that okay? You guys wanna try that problem out right now?
Yep.
Go for it. I'll stand here. If you don't want to, you can draw a duck. You can write a journal entry about, it is Monday, I'm back in calculus. I'm reconsidering all my life choices. Sorry, this jackass bad boy thinks he's funny. Oh, do you have not one of these? I got one. You can have one. Huh? No, I don't give you the formula. I give you a formula. Oh, one little thing I'll help you with, because I could have written this a little better. Do you see how this is the first 2 years? So let me help you out a little bit. So you want to iterate from what to what? 0 to t.
Oh, to T.
But if you put the t there, it cannot also be in here, so just change this back to x. That is something that the fundamental theorem of calculus kind of pointed out. You can't have a variable trying to control two different things. Like if you call this side x and this side x, it can't be a rectangle. Because they both are controlled. Okay, maybe that makes sense. You will end up with a function, a formula of t. And there's also another trap that calculus students fall into. When there's a zero limit on your interval, 0 to t, sometimes you guys just go, oh, I don't have to worry about that part. But it's e to the. That ain't gonna be 0. So can you guys apply that thing we just spoke about? What? This is e to the ax, yes? You could even, if you ever wanted to, take any constant multiplier, just take it out. You got less shit to look at. Especially if the multiplier looks like 456.078, whatever the hell that was. Just get it out the way. So, does anyone know what the integral of e to the point 1x is? E to the point 1x over 0.1, yes. Yes! Plus z. Not really, because we're going from 0 to t. So 200 divided by 0.1 is 2,000, blah, blah, blah. Okay, keep going.
For part A, will you leave it as an integral from 0 to t?
No. You actually do the interval, get the formula. I want a formula for the total. Now, technically, if I will let you could say, this is the formula. It tells you to take the integral, but I want it specifically to tell me that. I mean, you could just circle this and say, that's your answer, Jeff. I don't say you should try that. That would be bad. You're not gonna have a good time. Right? 200 divided by 0.1 is 2,000. You're evaluating between 0 and t. When you plug a t in, you get that. That's crazy. And when you plug a 0 in, what do you get?
Oh, 2,000.
2,000. 2,000, 0, 0. Party over. Oops. That is the formula. Now, real quick. What do you get when you plug a 0 in for t? Into this formula that we just created?
0.
Why does that make sense? Because after 0 years, how much have you saved? Nothing. All right. So you want your savings to be, what did it say? 1,500?
Yes.
Oh yeah, so, let's see. If the
Cost-
system initially cost $1,500, when will the owner make that money back in savings? Well, then you just take your savings equation
Plug
and
it
set
in.
it equal to 1,500, yeah. Then you're back in pre-calculus. Gonna have to use some logs and shit. Maybe just logs. Oh shit. I like this kind of problem because you guys get so used to a problem like the one before this, where you just integrate, you're done, integrate, you're done, integrate, you're done. No, integration in every STEM course you're gonna take after this is the first step. Integration, most of the time, comes from observations we make, we integrate that, we come up with a formula, and then we use the formula. As a homeowner, would I be interested in the answer to this question? Before I buy the damn thing, I want to know, will it be a few years or will it be 80 years until I make my money back? If it's going to be 80 years, I'm going to be dead. I ain't going to do it because it's not worth it. You guys are with me.
Yeah.
You might never have had to worry about this, and some of you guys maybe you have. But that's the kind of analysis you go into this kind of thing. You know, like, is it feasible? Does it make sense, or does it not? This is a huge part of that. Are you guys getting an answer, or does anyone know what you're doing? Set this equal to 1,500. Right, you would add 2,000, divide by 2,000. What do I do after this step? Yeah, take the ln. You could reduce that further, I don't give a shit.
Not that one.
Throw the old calculator in and then divide by 0.1 or multiply by 10.
Would it be over 20?
It would be over 20. Yeah, so then you multiply by 10. Throw the old calculator. I don't know why I want that to be 25. Now you're just solving for t. Now you're back in pre-calculus. Some of you guys are like, I was never there in the first one. Damn it. That's not good. Think you get like 5 point something?
5.596.
Okay. So about 5.6 years. A little over 5 years and 7 months. And then you can figure out is that sounds pretty good. If I just buy a house, I'm gonna put this on it. I'm gonna be here for more than 5.6 years. That makes sense. After that point, I'm just saving money straight. Okay. Maybe. Is that okay? So that problem is exactly the same as the bacteria problem, just with easier numbers to look at. They're exactly the same thing. Yes? What's up? No, I'm not. No, I know. Which- Can you imagine? Which one are we looking at? Alright, now, this is the crux of a teacher's dilemma. I have no way of, I would love it if I could see the problem through your eyes. There is something about this problem that just tells me exactly what to do. Do you see a
Unit.
function in there that's got, do you see a function in there that would take chain rule if I was differentiating? You all with me where I'm not differentiating? Do you all see a function in there that would take chain rule to do if I was differentiating? Alright, if you see that, then the first thing you think is U sub. Because U sub undoes chain rule. So if you see an inside function, what is the derivative of blah 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 x cubed? The derivative of blah blah x cubed is blah blah x squared, yes? Is that in there also? You guys with me? So if you see, it doesn't matter if the function is stuck in another function, but 90-something% of the time it will be that part. Do you see how 2 minus x cubed is stuck? It's stuck up in the power of e.
Oh, yeah.
So if I'm thinking U sub, that's the first thing I'm gonna try, and if that don't work, I'm like, God damn it, Jeff, what kind of weird shit have you done? The other more general thing that works 100% of the time is there something in there whose derivative is in there also? And I don't care if I'm missing a constant. I think I got you guys to that point where you understand this, yes? The derivative of 2 minus x cubed is negative 3x squared. Do I have a negative 3 in there? Why am I not worried? I don't have a negative 3. Why do I not give a shit?
Cause it's gonna go to
It's a
zero.
constant. What can I do? I can take constants in and out. Yes? So let me show you very directly. Somebody help me out. What am I gonna let u equal? 2 minus x cubed. So what du?
X.
Negative 3 x squared.
Negative 3 x squared dx. So do I have x squared dx? If I did not have x squared dx, I've gone the wrong path. It's only the constant that I can be missing. Because
Yeah.
do you all agree I can multiply anything in the universe? I don't give a shit where it is, I can multiply it by 1. And nobody's gonna get upset. And do you all agree negative 3 divided by negative 3 is 1? Yes. So I could take this inside and I can multiply it by negative 3 over negative 3. Yes? I could. Now listen. I'm just doing this for the benefit of anybody who still doesn't quite get what we do with the constants. You don't have to ever do this shit. Yes? So one of these negative 3's I want to keep inside. And of course that's the one on top, because then I can see this. Then I can find this, yes? I can find that right there. Shaboo! Put your glasses on, Jeff. Alright, Jeff. What do I want to get out of the way that I don't want there?
A negative.
The over negative 3. The 1 over negative 3, I want to take that out front. Jeff. What? Okay, there you go. Can you find du now? I can find it. There it is. There's du. So that is du. And of course, what's this? E to the u. Oh shit, sorry. I'm zoomed way too far. Come back. Come back. Okay. E, now do you all agree with me that the way I've written it now, do you all agree that e to the function, yes? This function's derivative is right there, yes? Isn't that what this says? E to the function with its derivative right next to it. These two say the exact same thing. That is just so much easier to look at. That is effectively what U sub does for us. Just makes it easier to look at what I got. Now, which part of this, did this whole thing make sense to everybody? Or was there stuff that didn't make sense? Some of you guys are like, everything. I don't know what to do, but
Oh, yeah.
got it. Okay, and then you integrate. Now, do you notice what I've left off? What do I still have to take into account? What do I still need to change? Have I changed everything that was X to U? No, I haven't. What have I left off? 0 to 2. Why can't I just put 0 and 2 here again?
It's not X anymore.
Because 0 and 2 are what X is doing. I need to know what the shit U is doing. What is U doing? This my grammar gets fantastic. Huh?
2 minus X.
Yeah. You know that U is 2 minus X cubed, so when X is 0, you can figure out what U is. When X is 2, you can figure out what U is. Yes? You set that up. You guys told me what the shit U is. You said to me, Jeff, U is 2 minus X cubed. Okay then, if X is 0, what's U? 2. So when X is 0, U is 2. When X is 2, what's U?
-6.
-6. There you go. See? That's all. That's it. That's all. That's it. So when I have a definite integral, I explicitly have to change all my X variables to U variables. If any X variables are left over, I'm screwed. I did something wrong. I need it purely X or purely U. And that includes the limits. Those aren't just numbers, they are the things that the variable is going from to. So if my variable changes, these will almost always change.
So you can basically, just essentially to allow you to use U by itself and plug it with the correct, like.
Yes. So I could have left 0 and 2, and that's what I did when I was a student. I left 0 and 2, but I put them in parentheses to remind myself that's not what X did. And then I brought X back at the end and I shoved 0 and 2. That actually is like this much more work, to be honest. So if I would have realized that, I would have done it, but I thought I was all like, ooh, look at me. But that was stupid. Plus, if you're going to take Calc 3 eventually, you want as much practice at messing with limits now as you can, because then you have double and triple integrals where all the limits are dependent on each other and you have to switch them and shit. You want some of this practice. And you're all like, oh good, I definitely want to take that now. How do we feel about that? I mean, U substitution is obviously integration by itself. Depends on how well you know your derivatives. Just straight up integration. If you know your derivatives, integration is easy as shit. Until you get something that's not immediately obvious where it came from, and that's where U sub helps. Can U sub help with everything? No. So here, real quick. Which one of these will U sub help me with? Get out of here. Well, I like this question. 2 questions, yes? A, B, yes? A, B. Which one will U sub help me with? This could be a trick question, but we'll see. Which one can U sub help me with directly? B, why? What's the part that's stuck somewhere? Yeah, 1 minus X squared. What's its derivative?
2X.
Close.
-2x.
So what you said was blah, X. Something X. Do I have something X in there also? Yes. Direct U sub. That won't work that way, will it?
Yeah.
Do you guys see that? This is a problem you could do an entirely different way once you get to Calc 2. Chapter 7 says, what if U sub just ain't working for you? Right? What about here? Real quick, last one I'll do, I'm sorry. What about here? Or here? Yeah, Jeff, you're so creative. I'm sorry, this is A and this is B. Which one will U sub work with? B, because what would you let U equal?
X squared.
And then what's du?
2X.
Blah X. Do I have X? Yeah, so I can make blah show up. I don't care what the constant is, I can make it show up. If I need a 2, I put a 1/2 out front. If I need a 1/3, I put a 3 out front, right?
Yeah, you don't really.
Constants I can make happen.
I mean, A is easy.
Why will A not, no, okay, do it. Sorry, Ezekiel,
Sorry.
don't ever say that something's easy,
Okay, perfect.
because it ain't.
Looks like it should be.
No, but it looks like it should be. There's not a lot going on with this, is there?
Yeah.
If that wasn't there, is that easy?
Yes.
Hell yeah, if that wasn't there, is that easy?
Yes.
Hell yeah. What do I take the derivative of to get this?
Looks like a product.
There's no product rule with integration though. And if it was from a product rule, shouldn't there be more parts? Do you see what I mean? This is actually related to this you cannot do. This, you guys, with everything you learn in this class, you cannot do it. But this is the very first thing you learn in Calc 2, is to do this problem.
Oh,
Yeah. And it's called integration by parts. So, just to kind of show you, one level I need you to understand is, not only do you have to know how U sub works, you have to really see why you need it. And then you have to see what are its limitations, right? I can't do shit for me in part A, so then I need to develop another way of integrating. Can I integrate, is there a way to integrate by hand everything? No, here's a very simple example, and I'm sorry, this is the last one I'll do. I'm sort of taking over. You cannot do shit with this. You cannot do shit with this. There's no way to integrate this by hand. We have to do it numerically, which means through a computer. I could get a really good approximation using something called Taylor polynomials. But to get it perfectly right, I have to go to infinity with this. I don't have the time. I can get a good approximation. Does everybody see why U sub won't work?
There's no piece.
There's an inside function, but its derivative is not in there also. Yes? This is the kind of problem where the people that do U, if you do U equals x squared, du equals 2x dx, and then you solve for dx, and I know some tutors have shown you that. I know some of you guys maybe took calculus before and your teacher showed you that. That's complete bullshit, I'm very sorry. Because then people make mistakes and think you can do this integral, and you cannot. Okay, maybe. Alright, I'm sorry, I'll stop. Yes? Yeah. Well, let's find out. So what if you tried, because this one's a neat one. Oh. They got it? Yes. You guys see the problem? Number 50? Why does this not kind of feel like it should work? It's kind of obvious. Can somebody just tell me obviously why, on first glance, this doesn't look like it's going to work? Okay, I heard this. Yeah, I'm sure. So, like, what would you let U equal? What would your first instinct be to let U equal? 1 plus x to the fourth. You automatically should immediately realize I ain't gonna go anywhere because what's on the top? Just x. You need a what? X cubed. You gotta see that. The more you can see that, the more you understand U sub period. Does anyone have a suggestion? It's really, it's not like, huh? What about x squared?
Sorry, why would we need x squared?
You could break that.
Oh, x cubed. If U is 1 plus x to the fourth, what's du? If U is the bottom, what's its derivative? Something x cubed.
Yeah, that makes sense. The option B is derivative.
If you let U equal x squared.
Good. I was gonna say, I just gave something away when I thought Ezekiel was talking about x squared. How do we write x to the fourth as x squared squared? Now, real quick. If you're sitting there going, okay, number one, I don't know what the hell good that would do me, and number two, how would I see that shit? What would you need on the top currently for U sub to work directly? X cubed. Is everybody with me? What is up there? What does it go with then that I would take the derivative of to get there? X squared. Alright, I need you guys with this. Is such a cool. So if my first instinct for what U should be leads to the wrong thing, I'm like, oh man, I don't have, then think the other way. What do I have and where would it come from? X would come from x squared. Do I have x squared? Yeah, I got x squared. So, and you're all like, this stuff just keeps getting better and better, Jeff. Alright. I understand. I hope somebody out there is looking at this the way I do, and it's kind of like, ooh, that's cool. Ooh, there's another thing. Ooh, and I understand how if you're sitting there going, oh, there's a whole, oh shit, there's a whole other thing it could do. Okay, so I got this. Oops, it's the next on top. If I rewrite this like this, now again, what told me to try to do that was the thing I had available was x dx. And that would tell me I have to let u equal x squared. And then I go, well, can I see an x squared somewhere? Well, I can if I write it like that. You guys with me? And this is why it's so important to ask questions from homework, because I've assigned this problem specifically so you can see this kind of thing happen. If you don't see it and you don't ask about it, you don't even know to look for it, right? Okay. So if I let u equal x squared, what happens from there? What's d? And that's the easy part, right? How do I get a 2 to show up? I'd love it if somebody went, you just put a 2, Jeff, and then put a, so overall I just did nothing. It's that straightforward. I don't have to solve for dx. I don't have to, if you do, if that's the way you were taught and you like it, great, just be careful. This is better. Not just because it's the way I do it. Well, yeah. I don't know, anyway. You just make less mistakes from what I've seen. Do I have everything? I got my u, I got my du. I can rewrite the integral in terms of u. And this is the one, well, I don't want to give it away. The answer to this new formulation, 2x dx is du, and then x squared is u. This is the one of this family of functions that I said you had to memorize. It's the inverse trig stuff. Inverse tangent. That's the one inverse trig function I said you needed to memorize because it's the one that shows up the most.
It was negative root without tangent.
Yes. So this would be, why am I doing your homework for you? You guys can finish that. That's enough. Is that okay? I think the main thing there was, now you realize, in general, if you have an x to the 4th, you could look at that as x squared squared if that helps you. If you have an x to the 6th, you could look at it as x squared cubed or x cubed squared. Then you got this whole family of things that suddenly u sub worked for that you didn't realize it could. Okay. Yeah.
And then use that and combine that with moving like a number to the line, essentially kind of manipulate like what.
Yeah, the x squared is stuck. You just can't, it's so stuck you can't even see it at the beginning.
Yeah, so you
Yeah.
gotta manipulate it the whole thing, make it like.
Yes.
Right, okay.
What's up, are you?
Can we please go over 4A on the practice test?
Since you asked so nice. Let's see. Do I have any left? Any practice tests? I should. Or have I given all my practice tests away? What's it say?
It's
think I
the
gave them all.
indefinite integral.
Ooh, I have one.
Oh,
Sorry. 4A.
yes.
Oh, this guy.
Yes.
Yeah. Now the funny here. 4A is funny because 4A becomes hard the more you've learned. Because you're trying to put it into a category it don't belong in. So students will look at 4A and they'll say, okay, U sub, what do I do? How do I? No, it cannot be U sub. You tried. You know it ain't U sub. Think of this as being in the first section where we did integrals. So we don't know U sub, we don't know any of that shit. What is it I keep telling you over and over? Before you do calculus, simplify. So cube that top out. The bottom is how many terms?
4.
So if I make the top several, I can just break it up. And then integrating each piece is easy. Does that make sense?
Yes.
But do you see, can you guys see how 4A looks like it should be more complicated, like a U7. It's just crank that thing out, divide each piece by 2x, brute force, because U7 ain't gonna work on the thing. Well, maybe it could make it work, but no, it's not gonna work.
Okay.
Cool.
Yes.
No.
You're saying, like, you just, instead of, you guys just multiply, like, x minus three.
Times x minus 3 times x
Like,
minus 3.
multiply that out.
Yeah, if you guys remember Pascal's triangle, that's
That's what
quicker.
you're saying.
Yep.
Well, then you can just, like, you would probably have it in, like,
I tried to.
a few different, couple different pieces, you could, like, separate.
Yeah, just like 4D, right? Same idea.
I think you should be able to at least partially simplify it.
So you know, you guys, you know I'm gonna give you problems like that, where if you just simplify it, it's either easier or it's doable. Right? If they give you some ratio, like x minus 2 over blah blah blah, and you're like, you sub ain't working, and then think, let me factor the blah. Maybe the dumb thing cancels. Right? It's just a generally good thing to put first is, can I simplify this thing before I try to do weird shit to it? How did 3A go, by the way? Did everybody try 3A out?
Yep.
So what functions are in the interval of 3A?
The sine x and the cosine.
Yeah, sine x and cosine x is being squared. Is there one of them whose derivative is in there?
Cosine squared.
Now, real quick. If I let u equal sine x, is its derivative cosine squared? No. So I shouldn't let u equal sine x. So I should let u equal cosine x. And cosine x's derivative is negative sine x.
Oh, and you can move this.
So I've got a function whose derivative is in there, missing a constant, who cares?
Yeah, you can move it to, like, 2 to the outside, right?
So like negative u squared.
Yeah.
Move what to?
No, sorry, cause that case, like, the negative, if negative sine x is the derivative of cosine x, right?
Yes.
Then
So you'll end up with an integral u squared.
then it'd be a negative, so that'll watch it, the derivative of cosine squared.
Do you guys want to try that?
Yeah.
Go for it.
Well, you have it as
Oh, wait.
negative u squared.
No. I already did. I told you the first step. What was the first step? Can somebody remind me?
So
U equals cosine.
Let u equal cosine. Try it. If you get stuck, just kind of hang out and stare at me, and then I'll come in. I'll do some stuff.
This is somewhere along.
Where's shit? Did I start that? That's useful.
Something I kept on to is for you to change the limits or switch it.
Oh yeah. Okay, so where?
Oh, cute. Okay, you're right. It's not cute.
Yeah, that'll change things. But your general idea is correct. Yes, your general idea is correct. But that'll change things a little bit. But your, what were your limits?
Is that supposed to be a cosine x?
Oh,
Is that 5 or 2?
you know what?
No.
It's up here.
Oh.
Yeah.
Oh,
I
what's
tried-
this?
I looked
Okay.
at one similar, so I
So
could
your
find
limits
this.
should be numbers. That looks better.
Okay.
Oh, I also have.
So this one is showing you this one. This is
Oh yeah, yeah. Get on my last copy. I think it's gone. Oh, I'm gonna copy this too. Yeah, what was it, pi over 4 to pi?
Yes.
Sine cosine squared. One little thing that some of you guys might not worry about, but might help others, is to realize this is the same thing as this, yes? It's not a major thing, but it's actually trips people up to remember that's just a shorthand way of writing this. So we don't have to write the parentheses, because yes, we are that lazy math people. You guys see how that's helpful? Okay. So let me catch up with you. We all got this far. Cosine x du is negative sine x dx. So all I'm missing is a negative. Why are you rewriting it, just because? Okay, so now I got my negative. Whoops. So can I find du? Yes, I can find du right there, yes? There's du. I could literally put that there because everything's multiplying and I got commutative property, blah, 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 blah. So these together, with their powers combined, make du. How could I rewrite this chunk of it?
U squared.
Yeah. And now the only thing I have to worry about is the limits.
Changing the limits.
Yeah. This is what x is doing. I need to know what u is doing because now I have an integral over u. Do you all agree? If I have a triangle from 0 to 4, I could like smoosh it and make it go from 0 to 8. I could like smoosh it. Yes? If I have like a thing here, a piece of clay in the shape of a triangle, I'll smoosh it and now it's gonna go further out because I smooshed it. That's basically what u is doing. The original shape went from pi over to 4 to pi, and then I smooshed it and I reorganized it. Now it can be going from something to something else. Because I've literally physically smooshed the damn thing. Or smooshed it this way, or stretched it, or whatever. So now when x is pi over 4, what is u? Don't give me no damn decimals. You know what else my calculator says, Jeff?
Right, 2 over 2.
Yeah, it's rad 2 over 2. And when x is pi,
Negative 1.
u is negative 1. And now that's a relatively simple integral with relatively worse numbers than you'd want to plug in. Who cares? I don't seem to care.
And we'd be switching the limits, right?
Do it again.
We'd be switching the limits because of the negative.
If you want to, it doesn't matter.
So it's the same.
Integrals don't care if I go forward or backward.
Okay.
But if I do switch the limits, I do have to make it positive. So you could make the whole integral positive and flip. That's not a bad idea because negatives find a way to mess us up. You guys understand what I'm saying? If you wanted to. There's not a damn thing wrong with just doing this directly. But I could do this. Yes? Because when I switch from A to B to B to A, the sign changes. Yes? Which only makes sense because the width is B minus A. If I switch the order of it, it becomes the opposite sign of what it was. Do you have to do that? No, but it's not a bad idea because negatives screw us up all the time. Right? So if I have a negative that I can kill, it's not a bad idea. Now, I need you to really hear me. If there's something more fundamental you want to focus on, trust me, at least 10 other people want to also. So if you're like, okay, that's a lot just happened, and you just make a problem that focuses on this, we could do that. I don't understand what happens when you change the, okay, we can do that. Right? I mean, this problem's got a little bit of everything. It's a definite integral, it's a u sub problem, it's a change in the limits, it's got a lot going on. This
We go
Oh shit, I gave my last one away. What's 4B say? Can I see somebody real quick if it's really involved?
For that one, you just break it. It's the same as number one.
Oh.
Oh, 4B, sorry.
Okay. Two really good first steps on this problem. One should really something we do every damn time because of the rules we have that we know. What's one really good thing to do?
A second.
Yeah.
Oh,
How much have I ranted about how I wish we didn't come up with root notation in the first one? So, fractional powers are just so much better than radical notation. Why? Because I know x to the n. There's a rule for that. So, and the second thing I'm going to do at the same time that students forget you can do, I can separate the damn things. I can do the integral of this shit by itself minus the integral of this shit by itself. Yes? Yes? Whatever, Jeff, you're the teacher. No. What does that symbol mean again? True, antiderivative, but what does it literally directly mean? Why does it look like this? Because what is it related to?
Summation.
The sum. It's just the letter S and they just stretched it when you were smart. Let's put that there. Right? If I'm adding up a bunch of positives and negatives, can't I add up all the positives and then subtract all the negatives? Can't I do that? Because they're all just on the same level of PEMDAS, yes? They're both at the ass end of PEMDAS. Addition, subtraction, yes? So of course I could split the dumb integral out. People get this problem and like, I'd like to use U sub, but it doesn't work on that part. Then don't do that shit. Just put it off to the side. So I'm gonna do two things. I'm gonna rewrite all my radical stuff in, you can do it, Jen, fractional power form. And I'm gonna split these dumb little things up. Okay. So now I have two. The second problem especially should be like, hell yeah. Yes? The second integral. And by the way, real quick, be really careful. Just remember the simple thing. How do I know what goes on the bottom? Which number goes on the bottom? The root, like most plants, roots are on the bottom. Right. If you write that the wrong way around, the whole problem's wrong. But is everybody cool with me saying this is easy as shit?
Yeah.
This step is easy as shit because it's x to the n. And I know how to do that. In fact, let's just do that first. What's the integral of this? X to the what power now?
7 4.
7 4, so you gotta add 1. Yes, gotta go up by 1. 3 plus 4 is 7, 7 fourths. So what's gonna be in front?
4 thirds.
Nope. New
4
power.
7.
Yeah.
Sorry.
That's why you find the power first, and then you reciprocate it. That's the rule. That's the rule.
Right.
That's the rule for x to the n.
Are you allowed to bring that x to the half up?
The who?
Oh, on the
Oh,
other-
this?
Yeah.
I mean, if you want to. Yeah, you could.
That's what I did.
Because what are, no, okay. Is everybody cool with that second part? I saw a few of you guys looking like I was crazy, but I mean, my God, if you can write it as x to a power, I don't care what the hell that power is. It's easy. Unless it's x to the x. It's gotta be some kind of constant. Now let's look at the first part, the first integral. Any suggestions? Joanne said, not a bad idea. She said, we'll just take the x to the 1/2 up. Maybe I'll see something. So what's it look like if I force that x to the 1/2 up top? What would it become if I force it up? X to the
X to the
negative 1.
half.
Now, can anyone see what part of this problem is screaming to me what method to use? I don't know what that is. So what's the first thing I do? If I'm like, if it's not integral of sine x, and it's not integral of x squared, and it's integral of blah blah, holy shit, what's the only other way we know to do anything? To integrate? U sub. So the minute it's not just a direct, well, it's this, it's U sub. It has to be u sub. So what would I let u equal? Not e,
X.
x to the 1/2, yeah. Now, real quick, as I say that, there actually is a way, I think that might actually work in a weird way. Yes, that would work. That would work, Paola. Is that what you did?
Well, it's just I'm thinking if you let the exponent be u, then you don't cancel the x as a du.
Well, let's see.
It will be u.
You ready?
It will
Let's
be e
see.
to the u over u. Right?
Well, let's see. You ready?
You're gonna add.
What's du?
1/2
x to the negative 1/2.
There you go, right? So I've almost got it. I've almost got du, don't I? What am I missing?
The du.
The 1/2, right? Okay, let me stop. Let me stop. Let me stop.
Oh, so now I just put the 1/2 on the outside of the row, right?
Well, no. I need a 1/2 that isn't currently there. Is everybody cool with what I just said? What does du need? It needs an x to the negative 1/2. Do we have an x to the negative 1/2? Check. It needs a dx. Do we have a dx? Check. It needs a 1/2. Do we have a 1/2?
No.
Shit.
So,
So I need a 1/2 inside. So what I need on the outside? 2. So overall, I did nothing. I can't change the problem. You can, but you'll lose a lot of points. I see your problem, Jeff. I'm gonna do this one instead. What's more important than anything specific about this problem is why did we do what we did? The inside function inside of E was more than just x. That's related to chain rule. What's integration's answer to chain rule? U sub. Let me let u equal the inside, dude, and see if it becomes related to what's on the outside. In this case, it did. All I'm missing is a 1/2, and I make that work by putting a 2. Now do I see du?
Yes.
Yes, I see a du right there. And what does this become? This is gonna be du. And then I got all this other shit. Blah 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 blah. And then that's easy. Right. Then your old e to the u is, and then you just replace u with what it was, yeah, because this was indefinite, right? If I remember correctly.
So e to the x to the 1/2 plus.
Yep, it'll be 2e to the x to the 1/2 minus 12 7 x to the blah blah plus.
when you put that, this in parentheses, and it subtracts the other stuff, right?
Yep. So don't forget, anytime you want to, if you have terms separated by pluses and minuses, you can break that integral up. And do you guys see the mistake people make? They go, oh, I need a u sub here. I need a u, but that doesn't work for this. I don't need it to work for this because I can separate that. That's its own problem now. It'll work for this. Yeah.
A question about the C's here. Each side will have its own plus C, does that make it 2C?
Not really. I could have put this here or not yet, as long as I do at the end.
Okay.
If I wanted to be hyper, in fact, if I was getting you ready for differential equations, math 245. Is that right, Jeff? 285? I forget. 245 is discrete. 280. I would have put plus C1 plus C2, and together they make plus C. Each one will come up with its own constant. But what's a constant plus a constant? Another constant.
Okay.
So normally what we do is we call one C1, C2, and then we even make it C3 at the end.
Could you use different
So it
variables,
would-
like put plus d plus c or something?
Hell yeah. In fact, that's what you should have done when you had the second derivative of double prime and you had to work backwards. You should have done plus c plus 1/2 c squared plus d, blah, 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 blah. Yes, you could have used C1, C2, but normally what we do is you use C, D.
And what would need to put that radical back on the bottom?
No, 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 no,
Oh.
no, 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 no. Okay. What is the integral of this?
E to the u.
Is that cool? Right?
2e to the u.
E to the u minus 12 sevenths x to the 7/4 plus c. This is not right because I just replaced u with what it is. I need you to understand. There used to be a bottom. We integrated, and that's what we got. I don't have to go, oh, I gotta bring the bottom back. No. No, it comes, where does the bottom come from? Where does the bottom that's here come from? Right, Joanne? That's what you're worried about. You're like, it's not there anymore, but it was there. What's this guy's derivative? It would be 2e to the stuff times the derivative of the stuff. Won't the derivative of stuff have an x to the negative 1/2? With a 1/2, right? So then it would go on the bottom.
Okay.
So trust in the form of your answer. You never have to carry anything from earlier. When you replace everything with you, this is where you are.
Okay.
You don't have to worry shit about where you came from.
Okay.
Where's the bottom? The bottom is in here. It's in here.
Okay.
du had the x to the negative 1/2, right?
Yeah.
So it's still in there. I just made it look a lot better.
Okay.
Yeah.
Since it was separated them into two intervals, shouldn't there be two plus C's? And then there's
We
no-
just had a discussion about that.
Oh,
I could have done 1 plus C1, 1 plus C2, and then have plus C3 at the end.
well, I thought they would cancel because you're subtracting one.
Oh, no. How do I say this? When I iterate that part, the plus CC could be negative. But the two C's aren't the same. Why would they be the same? They don't have to be the same. Okay. No, you can't come in. Okay. So don't worry if you split an interval up, you don't need multiple C's. Just at the end, put a plus C at the end. Because whatever all the constants you get, go together and make super constants. Anytime you want to. It's not a bad idea. You know this, but it's a good idea to do this sometimes. Just take the derivative of where we ended up. Show yourself it does, because it's nice to see things like that bottom coming out, right? When you do that and you show yourself, oh yeah, it's coming back together to what it was. It's good to see it. You can know all day long that this guy's derivative is that, but if you show yourself, you're like, oh, okay, that's where that came from, that's where that came from. Okay, maybe. Some of you guys will look at me like, no, I'm not gonna do that. So- Can't believe it's already 2026, just a month stuff. Feels like just yesterday we were all worried that the world's gonna survive 2020. Most of you guys were like 4s. No idea how close we came to total annihilation. So again, just reminding us, we don't have to do the problems that are on here. If there's something that doesn't make sense, we can focus on that. We can focus on just that.
Oh.
Yeah.
I don't know if you, but as far as like 4H, I just had a question.
For A,
No, 4H, I just wanted to ask a question about that. They didn't want to do it. Had a specific question relating to it.
for H,
Yeah,
okay, I'm with you.
you're right. I just wanted to ask if you could just, given what we did earlier, is it possible to divide them in, or break them up into two different entities?
No.
I wasn't sure if multiplication, I figured that might not work.
Yeah, really quickly. Just because I'm really happy you asked this question, Ezekiel, because people don't realize it. So what he's saying is, if I had something like this, could I split this up into two different intervals? Yes? You with me? Hell no. And here's a really quick example why. Is this a difficult problem? Can you guys tell me what the answer is? Can you guys tell me what the answer is?
1 over 3 x cubed plus c.
Do you all agree this is the same problem? Do you all agree that's the same problem? Same problem, yes? You all agree that's the same problem? Please say yes. So if I thought it did this, what's the integral of x? What's the integral of x?
X squared over 2.
And what's the integral of x?
X squared over 2.
And that would be 1/4 x to the 4th, which is very, very different, yeah. So you can only, and why is that? Why is that, Jeff? Why the shit does all your math not be nice? Why can't your math be nice? Math boy. Because, what's that symbol mean again? Sum. Sums do not operate well with multiplications. I can't break up a multiplication when I'm trying to add. I can't. Now, sums work really well with additions and subtractions because they're the same dumb thing. That's why I can break things up on the addition subtraction level.
It's just a matter, it's just because that doesn't reach the order of operations, you can't.
Yeah.
Multiplication goes first.
Yes, there you go, even better.
Yeah.
Good old, please excuse my dumbass son.
I mean, the integrals are just gonna express.
We're around Sally.
So, just have to-
Or one year, my student said, it's please excuse my deficient algebra skills. But anyway, to remember
Do
it,
H of 4.
PEMDAS, yes. Okay. So don't, also, real quick, let me see. I still see stuff like this, and it's kind of related to what I just did. I still see people doing stuff like this. Okay. Is that an issue? Is that an issue? The square should be on the inside, so it's actually doable. But they did it wrong way. Square should be right there. Jeff and a half. Stay with me. They've done effectively what you just asked about. But I've seen so many people do this in the little bit of homework I got. Anyway, this piece, anyway, that piece. Yeah, Jeff. In fact, you left the negative out and blah blah. But it doesn't matter. That cannot possibly be the answer. Can't. It can't. Because this would be product rule, yes? If I try to check myself, I get a lot more terms than that. That I effectively integrated parts of a multiplication. We just got done talking, we can't do that, but I see so many people do this. You're like, oh, sine, I know it's integral. No, you can't do that. It's not the only thing that's in there. Maybe? So what way should I do this problem? Of course, if I could just write it right once, that'd be great. Here, Jeff, here. Be
It'd
quiet.
be X by
I gotta make sure you understand the x is being squared, yes. How would you do this problem? Let me see, I might as well write like this. There we go. Is that, alright, I might as well write like that. How would you do this problem? Is it just sine? So can you just go cosine? Nope, it's got extra shit. It's got an x multiplier, right? So it's the only other method we know. So, so the minute it's not like a direct thing, integral is secant squared, is tangent. The minute it's not one of those, the only other thing we know is u sub. What tells me u sub's gonna work?
the X squared.
Yeah. So function whose derivative is in there also.
Yeah, or something that can be manipulated to be different.
Yeah, exactly. If I'm missing a constant.
Yeah, you might need to like, add a constant. Or
If that wasn't there, that's another one of those impossible. Not just we can't do it at Calc 1 level. Impossible.
just flat out.
Put that there, easy. Take it away, impossible. That's kind of nifty.
Can we do 4H on the
Oh.
practice test?
What's it say? Oh wait, didn't somebody ask me about 4H? Oh, that's the one. E to the 3x, right? That one?
Yeah.
I don't remember. Minus 2,
Minus 2 times
the 5th root.
5th root e to 3x minus 6x to the 4th power dx.
And it was from nothing to nothing, right? It was empty.
Yes.
Alright.
Indefinite.
Alright. On this problem, there's a few good first steps. Like, you might see what to do here, or if you're not sure, you could always at least rewrite the radical as a power.
Rewrite it and bring it up.
Can anyone though just see what kind of problem this is? Yeah, it's gotta be a U sub, right? It's stuff times fifth root of other shit. No, that's not gonna be just an integral we know. Nobody has that memorized. Okay, so let's go ahead, let's rewrite it, because it might be a lot of you guys' first step. So I would write this as what? E to the 3x minus 6x to the
Like four
Five.
fifths.
4/5.
Okay, that's what's throwing
Now that might be a little bit cleaner. You can
Yeah.
definitely see what's on the inside now a little bit better.
me off.
So I mean, like I said, 97% of the time you let U equal the part that's stuck inside somewhere else. So what's stuck inside something? E to the 3x minus 6x. So you let U equal it, even if you can't currently see how it connects. You're like, it's gonna have too much shit. We'll do it and find out. I don't know. I just made the problem. I don't know. So if you let U equal this, what's its derivative?
3 e to the 3x minus 6.
Yep. Dx. Does that relate to this through a constant? This is exactly 3 times this, yeah? So what does this need to become this?
3.
A 3. So what do I put on the outside?
1/3.
There you go.
Sorry,
Say it.
so you got a 3 on the outside,
No, you have a 3 on the inside.
and the inside, and then a 1/3 on the
1/3 on the outside. So overall, I just did nothing. I multiplied by 3 over 3. Go team. So if I give the inside a 3, put a 1/3 on the outside, and I write way more than I want to.
So this is
Now I can find my du. Yes? Does everybody see what I mean? Du is this and this. Do I have this and this? I do! There's my du. And then how do I rewrite this piece? That's the only part that I have left to do something with.
U to the 4 fifths.
U to the 4/5, and now that's an easy freaking integral. Yes?
alright, that's 4/5. That's what I was thinking.
You know, as long as you let it, that's an easy.
Yeah, it's 4/5.
Just remember, if it's indefinite, your answer better end up with the same variable my question had, right? So don't stop with U stuff plus C, you gotta bring the X stuff back. Okay. It's when there's it's when it's definite intervals, our answer's gonna be a number, so I don't care where it came from. The U's or the X's, it's gonna be the same number. Okay. So here, let me give you guys the answer key, so in case you've already done this stuff, you can see if I did it right. I think I did this on the plane on the way back. Good. Yeah, it's not intuitive, really. Not much. Not much. To a certain point. Yay, it's more just writing. Yay. but I need more of. No. By the way, while I'm thinking about it, how many guys are maybe have already signed up for 280 or will sign up for 280? Math 280? There's a class called Math 082. I'm gonna send out an email right now to my 280 students about it. 082 is a support class that's not connected to your 280 class. It's being taught by Brad Bolton. Brad's an awesome dude. You know Brad Bolton. And it's kind of like a support class for 280. So in there, you're going to talk about 180 stuff and kind of review it as you need to for the 280 stuff. Right? So it's in a little extra course, but it's there if you want to take it. And then, of course, you still have the CISL that you can come to, the Calculus Instructional Support Lab. That's still going to be there.
And it's a 1 unit.
I think it's 1 unit.
Two.
It should be. What is it? Do you see it?
I'm not sure. I'm getting in
It
there.
should be a 1 unit. It should be no units, to be honest, but someday we'll get there.
Well, usually the supports are like 1 or 2 units.
Some of them are 2, but I
Depending.
think we made this one 1.
Trying to remember how to self-service.
Quiz? I didn't get it back on the first one.
The last time you didn't get it back? Alright, huh?
Maybe you came in late.
Maybe? I'll have to check.
Might have come
Oh,
in.
wait! Here we go.
Professors, they already print out a practice quiz on Canvas. Or should I just
Do it
use
again?
one?
If you
Is there
remind me.
print out of the practice
If you
quiz?
remind me,
Alright.
I could do that.
Is there one attached to
Do it again?
Is there one attached to the textbook?
Is there a what now? I thought you were talking about the practice test?
Yes.
Is there one attached to the
What
textbook?
would I need to review from the textbook to also prepare for this?
Homework?
Yeah, would it just be the exercises or is there something that?
Sorry, Jason. Oh, here it is, okay. Do it, I'm sorry.
It doesn't matter, 'cause it matter.
There it is. Anybody come in and not get their quiz back? Anybody not get their quiz back yet? Oh. That'd be good. Yeah. This one.
This thing.
Or you can still make corrections if you want. Oh yeah. Let me give you this too. I went in and printed out the practice final just because I can tell you guys want more calculus. Wait. Okay. So I will have an answer key for this actually a week from today. So don't stare too much at the practice final for right now. Let's focus on this next test. Or, you know, there are problems on there related to this next test.
This new system for self-service gets on my nerves.
There's a new system?
Well, they went to, like where you have to log in through Microsoft.
Oh,
And
yeah.
So
The
when you're trying to get Canvas, it pulls it.
authentication, yeah.
When you're trying to get like the self-service, it pulls up Canvas. And when I'm trying to get Canvas,
Yeah.
it pulls up the
Yeah, yeah, I'm with you.
And I gotta sit and fight.
It's supposed to be
big system.
such a convenient thing.
No, it's for them to catch people cheating. It's for them to cut back on some of the AI use, I think.
Maybe.
Everything runs through Microsoft, so.
I don't know.
That was my, oh, I was looking at Math 280. This course. Are you doing Tuesday and Thursday?
What's up?
Are you doing Tuesday and Thursday?
No idea.
Can't see the teacher's name.
Doing what?
Oh, your class. Now I can see the instructor's name.
My 280?
Wall, are you doing a 9:45
I think so.
to 11:50 a.m.?
I could barely keep this semester straight.
Are we gonna have the I formulas on the test? Or-
Yes.
Okay.
Oh,
You're only teaching one
Ahead
section.
of time.
I got you.
They have an online at Cuyamaca for
They have a what?
280.
What?
280 online at Cuyamaca.
Yeah? They have a long line?
No, online.
Yeah, they have a lot of online. I won't say any more about that, so I can remain professional.
No, I'm just saying with my work schedule, that would be so much easier for me.
Yeah.
Yeah, but I need the in-class help too.
No, 280 online is much better.
They
than
have
one.
16 people waitlisted on that online. Crazy. Just makes it too easy for me doing that. Dang, 15 of that one.
Alright, let's do this. So guys, I had a really good question. They said, basically they said, what the shit's up with this infinite stuff? What's that one problem? It's one of the first problems where you have to do an interval but use the infinite sum approach. I mean, what's it say? Sorry. Integral of who?
1 to 0.
0 to 1?
X cubed minus 3x squared dx.
Okay, gotcha. And I tell you, you have to use this. So I will give you this here. What gets me started with this? What's the thing that gets everything started?
Want to get the anti-
Delta x.
of delta.
Because xi uses I steps of delta x to get somewhere. So I need to know what delta x is first. What's the formula for delta x?
A plus.
B minus A over the number.
So that's delta x. Second step. Immediately take delta x. Now, you can kind of see the steps here. Delta x gets things started. What am I going to shove into f? I'm going to shove xi, so of course I got to figure out what the hell xi is before I can shove it into f, yes? So how do I figure out what xi is? Where am I starting? Where am I starting? Where am I starting? Where am I starting? 0. There it is. This is from 0 to 1. Starting at 0. How do I find my first rectangle? Where the first rectangle kind of ends. First rectangle starts at 0. How do I figure out where it
Goes
ends?
to 1.
How far do I go?
To 1.
Delta x, which is
Over
1 over n. How do I figure out where the second rectangle ends? Plus 1 over n. So I take 2 steps of 1 over n. So that's 2 over n. How do I figure out where the ith rectangle ends? I take I steps, so I over n. So I'm going to start at 0. Always write where you start, plus I delta x's. So I just get I over n. Is that cool? It's always beautiful when the first number is 0, because then your xi is nice and short and sweet. Because it's 0 plus that. That's awesome. Delta x tells me how big each step is. How big each step is tells me how to get to the end of each rectangle, which tells me xi. Once I know xi, what do I do with it? What does it need me to do with xi? Plug it in. What's the function? Yeah, yeah. So what's f of xi? It would be f of I over n, which is I over n cubed minus 3I over n squared. Which looks so exciting. So then you just sort of simplify this. Are you guys with me? Didn't I do all this already? Is that okay though? That's the start. Then you throw everything in and hope. It's all in there. I'm not going to do it again. I'm sorry. Just realized. It's on there. Didn't I do it? I hope I did it. Did Past Jeff on the plane go crazy? Oh, there it is. Look, it looks right too. Neat. Blah, blah, blah.
So you have to have those steps.
Do it again?
You have to write those 1, 2, and 3 steps for that problem.
I mean, you have to do those 3 things. Yeah. You don't have to write them exactly like I did, but you can't do shit if you don't do those. Yeah. It's not even me saying in order to get full credit, you gotta do this. It's just you gotta do that to do the problem. Yeah. Okay. Is that okay to get started? Whoever asked me that? Oh, okay. Is that all right? Okay. By the way, do you guys ever watch shows like Big Bang Theory or whatever else, and you see in the background these chalkboards with these whiteboards with, you're gonna start to go, wait a minute. I do that all the time. And I'll even be like, well, that's a lot of symbols, but it don't mean shit. Sorry. Big Bang Theory is pretty good about putting actual math at work, which I appreciate. So let's see, the funny thing with this, starting at 4-9, is 4-9 is the same thing as indefinite intervals. Yes? 4-9 was antiderivatives. Indefinite intervals are just antiderivatives. Are you guys with me? So 4-9's on this, but it's not really, it's in there already. Then you have to be able to do this process, but with like 4 rectangles instead of infinite. Yes? So make sure you know how to do that. Then you got this bad boy, and somebody asked me, am I gonna give you the sum of I stuff? Yes, of course I will. That'd be really evil if I was like, no, you gotta know it, all of a sudden. Then we move into U substitution, and then 6-1 was just, oh, that hasn't come up at all yet. Area between 2 curves, yes? Yeah. Oh, yeah, this was just, you found the antiderivative. When you started to try to do like a mixture, so once you get this, just plug a 2 into this, 0 into this and take the difference. Yeah. I'm just trying to show F top 2 works, yeah. Oh, yep. Oh, that's literally just do the antiderivative and plug it in. Yep, that's it. Yeah, so it's just trying to, there's gotta be a way for me to differentiate between do the rectangles thing versus just do the antiderivative thing. Yeah, so if I don't say rectangles, whatever else I mean, it's gotta be antiderivative and plug stuff in. Yeah. Yep. Broke it up, took out, you can take this out too. Yeah, and then you got the handout that tells you some y squared, some y cubed. Remember? Yeah, you got the Gauss thing for some y, blah blah blah. Okay, cool. Just to let you know, the CISL had like handouts you could get stamped and so forth for like extra credit. I'm also going to be able to tell who's gone in how much, right? I've got access to all that. So that's going to be sort of like a little fudge factor at the end. So if you end up with an 89.55, and you went to the Sissel a ton and so forth, and I saw you there, whatever, and I saw that you were going, I might push you up from a B plus to an A minus, right? Plus they just up directly. And I've seen several of you guys in there. More of you probably go when I'm not in there, you're like, I don't want to listen to this guy anymore. But whoever's in there that's helpful, that's all we want.
What was that UV thing for when you have a cube function?
UV.
Yeah, it was like, we have something like this to avoid all of this.
Oh, yeah. So that was the Pascal's triangle. Oh, yeah. Here. So remember this here? Alright, so here's how this really works. You ready? I can't remember if I showed you the whole way this works. First coefficient is 1, and it starts with all x's. The next coefficient is 3, and then it has 1 less x and 1 more negative 3. The next coefficient is 3, and then it has 1 less x, 1 more negative 3, and the next coefficient is 1, has 1 less x, and 1 more negative 3.
Okay.
And they just put all that shit together. It's a lot quicker than FOIL until you go insane. Yeah.
So I would look
You go
for the
insane
line.
a lot faster this way.
I would look for the line that matches the power.
Yep.
Okay.
It's kind of silly. Yeah. So it starts with all of 1 and then
Because this would be, it's opposite negative cosine.
yep. So it's gotta be negative cosine 2x. The inside does not change when we take derivatives, right? So it can't change when we take integration. We're just undoing the differentiation. So, do you see the inside can't be x squared?
Okay, yeah.
Because then its derivative would have had a 2x for the chain rule.
Yeah, no.
The inside's gotta stay the same. So you know the answer has got to be negative cosine 2x, but you could be off by a constant, right? So I would write negative, a little bit of room, cosine 2x, because I know that for sure. Now, when you take that guy's derivative, what number would effectively come out front of the chain?
Yeah.
We talk about just this piece?
Yeah, if you take this guy's derivative,
I'm gonna try that with,
you would get sine 2x times the derivative of this, yes. If you take this guy's derivative, right, would this be changed? The inside is 2x. So it'd be negative sine, it'd be sine 2x. All of that times the derivative of 2x. So here, just do this.
so A starts at
Just
0, 0, starts at 4.
take this guy's
This is like
derivative.
4, right? Yeah.
Yep. There, yeah, chain link, right? So you would multiply by 2, but you have an 8. So what must have been here already? So that if you multiply by 2 and it's 8. And then of course, so it's just, I know
Okay.
sine 2x comes from cosine 2x.
Why is it 4D?
You can write that down. That derivative though would have a 2 that would come out. It has an 8 out, so there must have been a 4 there already. You just, that's the way you have to think about it.
Understand that there's a negative cosine squared.
Huh?
The derivative of sine was cosine squared.
Oh, no. I thought you were making this x squared so that this was like the interval of 2x. Pretty sure that's what you did. Like, yeah, but you can't, the inside's gotta stay the same. The inside doesn't change.
So I see that people. Oh, but it's X.
Am I gonna do that?
Yeah.
Yeah. It's always, well, like on Tuesdays, I'm at 3:15 to 4:30. Monday, Wednesday, I'm 3 to 4.